Hi, everyone. My name is Gary Kelly. I am an adjunct professor here at Buffalo State, and I would like to welcome you to Math 103. This is a very different math course you're about to take. It is not long word problems and crazy long equations and all that kind of stuff. It's much more enjoyable than that. We're going to visit some various facets of mathematics you probably haven't thought about in a while, and I think you're going to find you're going to enjoy this very, very much. This is going to be a bit different because it's being taught via the internet, and all my presentations and presentations from other presenters will all be done by video, and we will be discussing all that situation as we go along. I will offer some times when we can get together on Zoom to go over questions you might have if you feel you need them. I'll explain all this to you in this particular video that you're about to watch. You're going to notice that I do the videos in sections, okay? So there'll be a lot of fairly short video presentations, not only by authors, but also by me. And I just want you to be aware that you'll have to watch them in order, and I will email all that information to you. So let's get started. The first thing I would like to do is share the screen with you with some points that I would like to make this morning or this afternoon or whenever it is you're listening to this. So here we go, okay? All right, as you know, the presentation of all this material will be made by video, watched outside of the class, all right, at home, in your dorm room, or at your apartment, wherever you live. And all the video locations will be on YouTube. And I will send you and email you all the video links. All you have to do is click on the video link and you will be brought right to YouTube, and you will be able to watch the videos that I'm asking you to watch. It's really a very simple process, okay? Now, as we move along with this course, you'll find you have watched a ton of videos. And as I have said just a few minutes ago, we will perhaps maybe have time, all right, to take a look at questions that you have with Zoom meetings. But generally speaking, you can watch my videos at 3 o'clock in the morning if you want, 7 o'clock in the morning, 4 o'clock in the afternoon, whenever it works for you. But I just want you to be certain that you keep up. Now, the course is kind of set up in a way that we do 2 days worth of course material every single day when you're doing summer school. And since if this is not summer school, then you will be divided into various different classes, okay? But for summer school presentation, I am going to, sorry, the clocks are ringing. We'll wait for them to ring here. All right, for summer school presentation, there'll be 2 class days worth of material that will be presented. But in the normal session in a normal situation at school, there will be 1 class per day. So when you receive your emails from me about the videos, each day in a normal semester will just have 1 day's worth of my videos. However, for summer school, there'll be 2 days worth of videos that will be available to you to watch. All right, let's go on. All right, so as I said, videos are watched outside of class, obviously. We can't get together due to COVID, all right? And as I said, the video locations are all on YouTube. I would suggest that you make certain that your email that you receive from me make sure they come to your phone, okay? So that you can use your phone even to watch the videos whenever you would like, okay? This way you don't have to necessarily be at a computer to watch the video presentations. Now, As you watch the video presentations, more often than not, you will have a sheet of paper that I will have emailed to you, which you can print, all right? And this emailed sheet will be a sheet that will let you follow along with my video presentations. So you kind of do the work along as I do the presenting, okay? To practice what it is I'm talking about, all right? I would just like to say another advantage of doing this by video is the fact that you can stop the video anytime you want when you're interrupted. You can also back the video up and look at it again if a point was made that you're really not too sure about. So there's a lot of advantages of being able to do video presentation. And as long as I offer situations where you can ask me questions in Zoom meetings, you should be just fine in this course. I wouldn't be too concerned about that at this point. Okay, so it's very important that you answer or you look at all your emails you'll receive from me, and you're going to receive a ton of them before this course is over. Now, I would like to say that I do not, I repeat, do not use Blackboard, okay? So everything will be done through YouTube and through Zoom. Your grades will be presented to you through a grade program I use called Micrograde, and I will print for you a grade sheet every now and then so you know how you're doing in the course. Now, I would also like to say, during my video presentation, if you can show me by emailing me and attaching a copy of the worksheet as you do it while I do the presenting, I will give you 10 points each day for those sheets. So it's a very simple way to earn points to help you do well in the class is to make certain that you follow along with the video presentations and you work right along with them, okay? And that will help obviously increase your grade. And I would just like to say also, there will be 2 major tests and 1 mother hard final exam at the very end, okay? So it is extremely important that you do well on these 10-point assignments that I give you each day to do along with me, that you do well on the tests, and also do well on the final exam. Now, your cell phones, you must make sure your cell phones are aligned to get your emails so that we can communicate. I also want each of you to email me your cell phone number, so in case I need to get a hold of you to find out maybe what's going on and why maybe you're not doing what you should in the class, I can call you and we can discuss it. And we also can talk about questions you might have, all right? So it's very important that I get your cell phone number. You will have mine, so you can text or call me, and I can text and call you so that we know what's going on throughout the class. All right, let me go on here. Okay, there will be video quizzes, I call them, every single class. Maybe 1 or 2 video classes. If it's summer school, there may be 3 or 4 video quizzes. Now, what these quizzes are multiple choice quizzes that I will give you on a video presentation. And all you need to do is write down the multiple choice answers and then text them to me when you have completed the quiz at the end of that class day, okay? So the video quizzes, as you're going to see, are designed to help make sure that you are understanding the material as I teach it, okay? They are not particularly difficult, but they kind of test your knowledge of what is going on in the videos so that I know that you are doing pretty well with understanding the material. So don't sweat the video quizzes. The video quizzes are just designed to help you stay on target with learning the material as we go along. How about taking notes? Do you need to take notes? If you like to take notes, you most certainly may take notes. on the video presentations. You may use any notes you have taken during any video presentation during a video quiz, all right? So there's no problem with you using your notes at any time to help you do well on the quizzes. So taking notes is a good strategy, and what's nice is that you can stop the videos as you take notes. In other words, if I'm going too fast, you can pause the video or stop it and just pick right up where you left off, and you can note down what it is you would like to note down without losing the idea of something else I am presenting, okay? All right, so hopefully that explains that. All right, let me go on here. Homework is often done by you at home, so not only will I assign very often videos for you to watch, okay, at home that I am not presenting during, okay? So in other words, you might be asked to watch 1 or 2 videos per night as homework, all right? And then we will go over the material in the next class, and then after I've gone over the material, you will do a video quiz, okay? Just make sure you understand it. So homework is a grading procedure for you in that when we do the video quizzes, obviously those are graded. They're usually out of 10 points. There's 5 questions, 2 points each, and you get 10 points for having completed the worksheets that I ask you to do. All you have to do is take a picture of them and text them to me, okay? And I will give you credit for those, okay? So you show up to my video classes online here, and you're going to score lots of points. They're going to help you do well in this course. So feareth thee not. Okay, let's go on. Textbook purchase. There is no textbook purchase. Please do not purchase the textbook. You do not need to use the textbook. I will be using pieces of the textbook in the course as we go along, but you will not have to buy the text. So we will not be using it, okay? And of course, I've said here again, your phone numbers, I need them, your cell phone numbers, so that we can text each other if need be. And of course, we will be Zooming each other as well. You will be watching all of these presentations using YouTube. You won't necessarily be on Zoom, all right, to do that, but you will click the link on YouTube and it will automatically bring up the video for you to watch, okay? The only time where you will actually have to bring up Zoom on your computer by yourself is if we're going to have a Zoom meeting, but I'll get into all that later as we get further into the course. Okay, now I'm sure you may have some questions, and if you want to text me some questions, you may certainly do so. My text is hooked to the email that I've sent you prior to this video, so feel free to shoot a text to me if you have a question about something, but fear not, you'll be fine in this class. We'll try to make it as enjoyable as possible. We'll try to do some kind of weird stuff in this course that will make you appreciate mathematics more than you have before. And if you already appreciate mathematics, I'm sure the course will be very simple and fun for you to follow. Okay? So, with no further ado, let us get started. Now, I want you to think about these questions, and I'm not really too worried about you sending me the answers to these. These are not going to be graded, but think of these particular questions and see where you fit in. Which statement that follows best describes your feelings about your mathematical career throughout high school and into college? As A says, did you enjoy all your math classes? Experienced learning from great teachers? Okay, that would be your choice A. B, did you hate your math classes? Took as few of them as you possibly could? And experienced learning math from many horrible teachers that were awful or sucked? Did you take And C, all honors classes in math? Were you horrible at math and took all basic math classes? Were both answers A and C applicable to you? In other words, did you enjoy your math classes? And were you in honors classes all the time? Or was it more like B and D? I hated my math class, took as few notes as possible, experienced learning from horrible, creepy teachers, and you were horrible at math and took most basic courses. If you'd like to text me your answer to these quiz questions, it'll give me an idea kind of where you're coming from, okay, what your background is. But it's not going to count for points either way. Next question. Which statement best describes your feelings about your mathematical career throughout high school? Did you mostly get A's, like A says? B, did you mostly get B's? C says, did you mostly get C's? D, did you mostly get D's or below in math? If answer D applies to you, is it largely due to your poor work ethic in your math classes? Or F, if it's answer C, you applied largely due to my poor work ethic in math classes? Or G, being poor in math and still trying hard, E applied to me? Or H, I was horrible in math, between liked and hated in my previous math classes. Okay, so if you'd like to respond to that question and send it to me, that would be helpful for me to see where you're coming from. Which statement that follows best describes your feeling about taking Math 103 this semester? I plan to give it my all and earn an A. I plan to give it my all and earn a B in the class. I plan to give it just enough so to at least pass the class. I plan to do as little as possible so at least to pass the class. I plan to give it my all and earn the best grade I possibly can. Or being poor in math and planning to try hard in this class, I still plan to pass this math class. So give me an idea where you are with that. All right, 4. Which statement follows best describes your feelings about what you must do to be successful in this crazy math class taught by Mr. Kelly, Math 103? Complete every assignment to the best of your ability. Attend, that means watch all the videos and actively participate in them as well, okay, by watching carefully and thinking about what's being presented. Prepare for each video and regular quiz. Be attentive during every class presentation or video. Keep your cell phone use under control while you're watching the videos, okay? Get help from the teacher during the office hours or the Zoom classes that I will offer on any topics that you don't understand to be announced down the road, okay? If having scored poorly on a quiz, get together with me on Zoom and perhaps we can help you improve your test grade so that you will indeed be able to pass the course. Or are you going to concentrate on all of the above components? So give me an idea for an answer to that from you also. Just text it to me tonight and let me know where you are with that. Okay, well, we're going to take a look at our first math problem. Which value here is equivalent to the number of seconds in 3 years? Assume there is no leap year. So in other words, all our years are 365 days. We're going to scratch the 366 days in leap year. We're going to pretend all years always in this class are 365 days long. Now, I don't know about you, but when I was taking math classes, I really had struggled with the idea of how to even start this problem, okay? Wasn't sure where I had to go or what I had to do. Well, I'm going to suggest if you took chemistry in high school, you learned a system called dimensional analysis to do conversions similar to this. So what we're going to do is practice the concept of that in this class. Dimensional analysis can lay out for you exactly how to do a crazy problem like this. Now, you know we're starting at 3 years, right? And we want to get into seconds. So here's all you have to do. Now, I use a smartboard type presentation when we're doing this material. So I'm going to the next page so I have more room. And I'm going to simply scratch down here 3 years. And I'm going to put it over 1. And I put it in parentheses. Now what I'm going to do, step by step, I'm going to figure out how I'm going to get this into seconds. Well, what is the next time frame down in terms of years below it that's smaller? Well, you might say months. The problem with months, if we go to months, months vary in size. Some months have 30 days, some months have 31 days, and of course February has usually 28 days. So I would avoid going to months, okay? I don't think I'd want to do that. I also wouldn't go to weeks, because if you try to go to weeks, what happens is, if you know that there are 52 weeks in a year, if you multiply that by 7, you're always short a day, right? So we don't want to do that. So always remember, our first step in going from years to a time frame lower than it, that's equal to it, we're going to go to days. Okay, now let me ask you something. You know how many days there are in a year, okay? If I wanted years on top up here, on top of this fraction, 3 years over 1, to cancel, like they do in fractions, where would years have to go so it would cancel out? Well, you know that years would have to go down here, okay? And what is the conversion of days to a year? Well, you know it's 365, right? So let's put the 365 up here. Now, units of measure cancel just like numbers cancel. Since I have year and years, I can cancel those. And if I did this computation, my answer right now would be in days. But I don't want the answer in days. I want it in seconds. So what's the next step down from days that I'm going to use, okay? What's the next step down? By the way, I should say this right now. If you'd like to do this, hopefully you have some kind of calculator at home there where you are living that you can use to do these computations. So that's what I just did. I just reached for my calculator over there. So I want you to make sure you get a calculator to use. I suggest a TI-30. That level of calculator should be fine. Okay, I don't think, if you have an old TI-84 or 85 from high school, you can scare that up for wherever it is, and you obviously can use it to do any computations we do in class. So obviously calculator usage is definitely encouraged and hoped for by me. Okay, so we're down to days. Now what we're going to do is we're going to attempt to go to the next thing down, lower. The next thing below days is hours, right? All right, so there are 24 hours in every one day, right? So where will days go so that days cancel out? Well, days would go on the bottom, right? That way it would cancel. And you know there are 24 hours in every one day. So if I did this computation at this point, all right, I would definitely be converted to hours, okay? All right, now that we have it in a position to get an answer of just hours, what's the next thing down from that? It'd be minutes, wouldn't it? So we got to get this 24 hours, or this, whatever the answer is going to be, down to minutes, all right? So let's see. hours is on top, so I just have to remember to take hours to the bottom, all right? And with hours at the bottom, okay, I will put minutes on top. Now, a lot of times people don't know where to put the 60. There aren't 60 hours in a minute. There are 60 minutes in an hour. So that obviously tells you the 60 has to go on top with minutes, right? So I put the 60 up here. That's the beauty of aligning the various different units of measure so that they cancel each other. Then you know to put the numbers that go with them in the correct locations with the correct label, all right, unit label. Well, this would get us to minutes, all right? And now we really want to be at seconds. So I want minutes to go away. What I want to go away goes on the bottom. For every 1 minute, all right, there are 60 seconds. Now notice the label on the final answer, the only label that's left that isn't canceled out is seconds. So I know we're going to have an answer that is in seconds, all right? So down here, I know my answer will be in seconds. Now, how do I decide how to get the answer? Notice all the conversion numbers are on top of the fractions. So what will I do? I will multiply them all together, right? Just like I do in fractions. If there were any on the bottom, any numbers on the bottom, I could cancel them with any numbers that are on the top to make life easier, but we don't have any in that position. Therefore, we don't have to worry about it. So I simply take a calculator, all right, and I multiply 3 times 365 times 24 times 60 times 60, and when I do, I get 9460800. So that would be the number of seconds, or in other words, 9,460,000. I did that wrong. There should be a 0 here. So let me erase that. Let me erase the commas. All right. Let me put this back like this. Okay. 94,608,000 seconds. That's a lot of seconds, right? And let's take a look and see if our answer is correct. 94,860,000 seconds is the correct answer for C. So you see, we've done it correctly. We have an answer that's there, looking good. All right, let's go on and try another one. Which value is the correct conversion for a speed of 1,100 feet per second? How can I get that into miles per hour? 1,100 feet per second. How can I convert it, again, to miles per hour? Well, again, I'm going to come up with a blank screen. I'm going to start out with what I have. So it's 1,100 feet per every 1 second. How fast would you be going in miles per hour? All right, to change this, I have to tackle the unit change in each of the various units. So I have to convert the 1,100 feet, all right, into miles, and I have to convert the seconds into hours. Okay, so which one do we want to tackle first? Well, why don't we tackle seconds first, all right? And we won't do any computation until we get to everything written down. All right, let's see, seconds are on the bottom. To make them go away, I'm going to put seconds on top. And if I know I'm going to minutes next, the next level up, okay, I know that there aren't 60 minutes in a second, there's 60 seconds in a minute, right? So I'm going to put my 60 up there, okay? All right, I have 1,100 feet per minute, but I don't want 1,100 feet per minute. I want how many feet it is per hour, right? Well, let's see, but then I'll do it to miles per hour. So let's see, what do I want to get rid of? I want to get rid of minutes now, right? Since it's on the bottom, I will put it on top. There are 60 minutes per every 1 hour. Okay, so minutes are gone. Now, fortunately, it appears I have my answer in feet per hour, but I want it in miles per hour. So what I'm going to do is, well, you probably don't know this, but there are 5,280 feet in a mile. Who the heck ever came up with that figure? All right, it's weird. 5,280 feet in a mile, 36 inches in a yard, 12 inches in a foot. Crazy. The metric system is so much better because it's all powers of 10. There's 100 meters or 1,000 meters in a kilometer. 1,000, that's an easy number. You can slide decimal points left and right to do conversions in the metric system. Not in the English system, it's a lot harder, but we won't get into that. Okay, so let's get this feet that's on top. We want it to go away. We want feet to be in miles. Now, are there 5,280 feet in a mile? Yes, there are. Or 5,280 miles in a foot? No, certainly not. Okay, so 5,280 goes here. All right, 1 mile goes on top. All right, so let's see what our final answer is. Well, we have numbers on top and numbers on the bottom. So what I'm going to do, I could cancel, but it's kind of a rough cancellation with 1,100 and 5,280. So what I'm going to do is I'm going to multiply 1,100 on top, get the answer to the top first, times 60 times 60, and I get 390 or 3,960,000, all right, on top, and I'm going to divide that by 5,280, and when I do that, my answer comes out 750 miles per hour. You are, sorry, look at that, miles per hour. I screwed that up, didn't I? You know what you're going to find out? This math teacher makes a lot of mistakes, and you got to keep an eye out for me on that. So what was left over on top was miles. What was left over on the bottom was hours. So we know the answer is in miles per hour. It's 750 miles you would travel in 1 hour. Okay? All right. And you can see our answer is there. It is choice A. Okay. Now, I've got some other questions I'd like to ask you today, all right, about different stuff in mathematics, okay? Which set of numbers here that you see do you think consists of members of the set of natural or counting numbers, the numbers you learn to count with as a little kid? Well, notice A has a lot of fractions in it, right? You notice B has a lot of heavy-duty decimals in it. The answer's choices. Look at C. Those numbers look fairly simple, right? You probably did learn to count with a lot of those numbers, right? So it would appear that the correct answer here would be C, right? Which group of numbers appears to show a generating property which after the first two numbers would tell you how to get the next number in the series? So see if you can come up with some method where we can predict what the next number would be in the series, given the first two numbers and how it works. It turns out that the number choice, or the choice we are looking for, appears to be choice B. Now, if you saw this, notice if you added 4 and 12 together, you would get 16. If you added 12 and 16 together, you would get 28. If you add 16 and 28 together, you would get 44, and so forth down the line. So it appears we can generate that series in B by adding the two previous numbers together to get the next number. We're going to be talking about some very famous series of numbers that were discovered by more or less ancient mathematicians, and we're going to see where they come from, some of these number relationships, as we get further into the course. Which figure that follows appears to be more aesthetically beautiful in appearance? I think most people would say probably D looks more aesthetically pleasing than A, B, or C. Can you figure out why? Well, if you think about it, if you look at the lengths of the sides of the figure in D, they all appear to be the same, right? And if you look at the interior angles on the figure, okay, pretty hard to tell without a protractor, but if you look at the angles formed on the inside of the figure, you notice they all appear to be the same also. When angles are exactly the same measure, they're referred to as being congruent. Of course, you remember that from geometry. And when the sides of a figure are exactly the same length, they are said to be congruent also. So we're going to be taking a look at these aesthetically beautiful figures more towards the end of the course, okay? And talking about some of the relationships. Which rectangle that follows appears to be the most aesthetically beautiful in appearance? Well, there probably would be a lot of discussion on this, but I think most people, when they think of the normal rectangle, they think of choice B. Choice B, right? Okay, we're going to take a look at that very special type of rectangle and some of the relationships that are similar to B there. And we're going to talk a lot about that kind of rectangle as we get further into the course as well, as you will see. Okay, which set of numbers described is most likely the largest in size? A set of numbers is a collection of the numbers, if you recall. Which of these sets do you think is the largest? Set of numbers which contains any decimal number that you can think of, including positive and negative numbers. Set of numbers which contains any fraction you can think of, including both positive and negatives. A set of numbers which contains any whole number you can think of, including both positives and negatives. And final answer is I'm not certain. Well, guess what? You can't be certain in a way here because of what we've discussed so far. We haven't really thought about it. Turns out the answer is going to be A, all right? And we'll get into why that is true as we get further into the course. If the time on a clock right now reads 10:38, disregarding AM and PM, what time would it be 38 hours from now? So where would the time be pointing at, if you'll pardon my expression, in 38 hours from now? Would it be 11:38, 12:38, 1:38, or don't we really know? Well, let's think about this. What time will it be exactly 12 hours from the time given, 10:38? Wouldn't it be back to 10:38 again? Now, it might be PM if it was AM when we looked at it first, but we're disregarding AM and PM. So if 12 hours go by, right, it's right back to where it started from on a clock. How about another 12 hours going by? So if 24 hours have gone by, the time is still 10:38 again, right? If we go another 12 hours, we're back again to 10:38, right? Okay. Now, how many hours have we gone through? 36 of them, right? 3 12s is 36. So to be 38 hours ahead of where we were, wouldn't that be 2 hours more later than 10:38? So it would appear our time would be what? 12:38. Now this is an example of clock or modular arithmetic, and we're going to take a visit to modular arithmetic to show you some very interesting coding facts that exist out there in the real world to help us for protection for various kinds of numbers. And we'll talk about that in entirety also in this course. A bank has a unique 9-digit numbers which identifies it. Every bank has a different number. It's called the bank's routing number. Now here's a question for you. Could all those ones, in fact, it turns out I believe there are 9 of them, could 9 ones be a bank's routing number? Routing number, by the way, is located on the face of every check. Every personal check you write or every check you receive as payment has a routing number on it. It's usually in the lower left-hand corner of the check, and it's 9 digits long, and it represents the bank or the organization which produced the check. Okay? Can we have all ones? Well, we're going to find out about that. Also, using modular arithmetic to help us discover the answer to that question. What is the probability of rolling 6 on a single die? Remember, a pair of dice is 2 dies. Pardon my French. All right. And I want to know, if you roll a die one time, what is the probability you will roll the outcome 6? Now, assuming it's a fair die, that it's not a die that's loaded, that gives the wrong answer every time or an answer every time, okay? What would be the probability of getting the outcome 6? Well, that's one outcome out of a total of 6, right? So I think you remember from your probability discussions in high school that the probability would be 1/6, okay? We will be discussing that. That will be the very last topic we will get into. If the probability of it raining today is 3/5 or 60%, you remember you can write percents as either, you can write probabilities as either percents or as fractions. And we'll review briefly how to turn fractions into percents, but you probably remember anyway. But if you don't, we'll go over it later. All right, what's the probability it won't rain today? Well, if the probability is 3/5 that will rain today, the probability that will not rain today is 2/5. You take 3/5 and subtract it from 1, and you get 2/5. Or in terms of percents, if the probability is written as a percent, you would take 60% away from 100%, okay? So the probability of it not raining today would be 40%. What is the probability of at least two people sharing the same birthday, that's day and month, not necessarily the same year, but day and month, in a room filled with 90 people? Now, something like this happening is referred to generally as a coincidence. We run into coincidences every day in our lives, okay? And this coincidence of two people sharing the exact same birthday, month and day, is a very interesting coincidence, all right? It's kind of a special thing for those two people. What do you think the correct answer would be? Now you notice I've written all the probabilities as decimals. The fractions have been converted to decimals by dividing the bottom into the top. You know what the correct answer is for this? It is C, 0.9999993. In other words, written as a percent, that's 99.99%, or rounded off. There's almost 100% chance that two people in a room filled with 90 people, two people are going to share the same birthday. Now that seems crazy, doesn't it? Well, guess what? You know, there's 365 days in a year. We only have 90 people. There's a 99% chance two of them will have the same birthday. Guess what? We're going to deal with coincidences as our last topic of discussion in Math 103. You know what? We must learn not to allow our intuition that we have from the past of things we've experienced to bias what really is the case often in mathematics, okay? As for example, that coincidence problem we just discussed. I'm going to give you an example to look at that involves this concept of letting our intuition bias what we think will really happen. Let me show you. Every surface has at least two edges and at least two sides. Is this true? Is it false? Not certain? This is a stupid statement? Well, look at this cylinder that this gentleman is running around here. You can see that it has to have two sides, right? There's the side he's running around on, assuming he can run upside down, and a side on the inside of the figure, right? Where he can run. So at least has two sides. And of course, the edges, I'll just kind of scribble along the edge here, and there's an edge along over here, right? Okay? So the question is it true that every single surface we can think of has to have at least two sides and at least two edges? Well, we're going to take a look at that today. So we're going to test our intuition a little bit, okay? What we are going to do is I'm going to ask you to watch several videos on YouTube that involve a particular situation similar to this. And we're going to discuss in those videos whether or not this really is a true statement, okay? So that's the next thing we're going to take a look at. So I'm going to ask you to look into those two videos, okay? Or several videos that I'm going to have on YouTube that you have the links for. I'm going to ask you to watch them. If you want to try to build what you see in the video, you most certainly may do it by taking strips of paper, and you can make them yourself and tape them together and try it with scissors and pens and so forth. to do this, but I want you to watch these videos, and I want you to remember we cannot always trust our intuition. Now, I'm going to mention that this is the end of your first class, so to speak. If you're in summer school, we have a second class to discuss, which I will start after you have watched these various videos that are shown on your email that I would like you to watch. And then we will come back and take a look at some very weird math problems that really make us think. All right? So please go to the next video, which I've asked you to watch in the email I sent you. Okay? We'll see you soon. Hang in there.